So
Thank
tell me a
you.
little about your early education and your career before you came here.
I grew up in Pittsburgh, and we moved around a little bit. I went to public schools for the most part, but I also attended some private schools. Um, I went to Cornell University, where I majored in chemistry, and that was the culmination of a lot of thought about where to go in science and whether or not I'd be a researcher. But I got very excited about the prospect of making new substances through chemistry, and also really helping to illuminate how the molecules of nature work.
Where did you go for your PhD?
So I also stayed at Cornell University. I had met a wonderful professor, John Clardy, who was an expert in organic chemistry, natural products, and also X-ray crystallography.
Yeah, great. And then what did you do after your PhD before coming to CABM?
So I had been learning how to use X-ray crystallography to determine the structures of complex molecules. But I was blown away when I learned that the same technology could be used to visualize the structure of human rhinovirus 14, which we were able to do through an amazing convergence of new technologies. And this was actually the first animal virus structure. I was very inspired by this. We developed new approaches, new methods, but especially gained so much new biological insight.
Well, it's very relevant to right now, of course.
That's exactly right.
Now, how long have you been at CABM?
So I joined CABM as the first faculty member hired by Aaron Shatkin in 1987. And as a result of my fervent interest in biological structure, especially viruses, I wanted to apply my skills to studying HIV. It was a death sentence for anybody infected.
Sure.
So I went to begin that effort at CABM. We set out to solve the structure of a key part of the AIDS virus, the reverse transcriptase enzyme. And I thought that that could be extremely helpful for developing treatments for HIV, because they were just sorely needed. So over the ensuing years, by the early 90s, we were able to solve the structure of reverse transcriptase, initially in complex with nucleic acid. And this was so informative. Also, especially exciting was that we were able to partner with wonderful scientists to actually develop drugs and successful treatments for HIV/AIDS.
And some of the structures that you found led to very specific drugs for HIV. Are they being used now?
Yes. I worked with Dr. Paul Janssen and his colleagues in Belgium, and we were able to use the structures to develop two drug molecules from a whole series of inhibitor candidates. And these drugs are widely used to treat HIV infection.
So you've been at CABM for 33 years now. You're still enjoying it?
I
Good.
love it. It's been a wonderful environment.
So what new project are you particularly interested in?
We were inspired partly by conversations with you to begin working on the SARS coronavirus 2 polyproteins. My feeling there is that this is a very understudied part of virology, and these are absolutely obligatory steps for viral replication. They represent not only fascinating scientific questions about how viruses work, but also could well themselves be the targets of new therapeutic development.
Now let me turn a little to your role at Rutgers. What school are you in? What department are you in?
So since I began, I had also been recruited by the Department of Chemistry in the School of Arts and Sciences, now the Department of Chemistry and Chemical Biology. And I've really enjoyed having my faculty colleagues in chemistry throughout my career here.
Because my next question is, so how do you interact with students in the course of a day, a week, a year? What are the main interactions?
Well, the interactions that I think are most important are to provide mentorship and guidance to young scientists. And this takes the form of, advising about research projects, experiments on a day-to-day basis. And there's also a great amount of interchange among the different members of my lab, including, senior scientific staff, postdoctoral researchers, graduate students, and undergraduate researchers.
In addition to what you're doing at CABM in the Department of Chemistry, any other roles you have here at Rutgers?
Yeah, so I've been teaching since I began at Rutgers, and one of my continuous roles is to be a professor in chemistry. Every semester I teach a senior undergraduate chemistry course, and this is great in terms of giving me exposure to what young scientists are thinking. And I feel as if I've been in college basically since I began as a result.
Great. Now, here's a tough question. Let's say you decided to retire tomorrow, and we were getting together the album about your wonderful career. How would you like to be remembered, scientifically?
Well, my overall philosophy is that I really love the beauty of nature, and to have the opportunity to not only investigate, the beauty of nature through scientific analysis and gaining deep insights. I also am proud of being able to use this information for the good of humanity. And so I think my great opportunities that I've had at CABM and Rutgers have been phenomenal as far as that goes.
Wonderful. Last question. Any important subjects that we haven't discussed that you want to tell all those people, the people who are listening to this right now?
Well, one of the things that I love about, the scientific research opportunities that I've had is that I've been able to work continuously on projects that I thought were of great interest and importance, since the beginning of my research career. One of the things that I've had the privilege to do is to not give up on really important problems. So certainly, if there's the chance, never give up on what are the most important goals, because when you actually get to a point, say the top of a mountain that you've been trying to climb, you'll see new things on the other side. And this gives, fantastic and unexpected insights and new places to go.
Very inspiring. So thank you, Eddy, and I hope everyone will enjoy your interview. Okay.
Thanks so much, Marty.